Alright, so I just want to go over some more practice problems. It looks like some of you guys need a little bit more practice on triple integrals and how to set it up and also how to evaluate some stuff. So this is number 22 on 15.6. 15.6, or sorry, 15.7. So 22. So it says find the volume of the solid that lies within both the cylinder and the sphere. Okay. So we have a cylinder and a sphere. So we're going to go straight to either cylindrical or spherical, right? So since we have this portion, we'll go to cylindrical because we have z here. So we know this is going to be r squared is equal to 1. This is going to be r squared plus z squared is equal to 4. So we know r is bounded between 0 and 1. And here we have to solve for z. So if we take the square root, we now know z is bounded between our circle, the plus or minus. Okay. And since, again, right, this is a cylinder, so basically what's happened is I have a sphere, right, a ball, and I have a cylindrical. So I'm looking for what is that portion there. So it lies within the both cylinder and the circle. So all of this stuff right here. Okay. So that means for theta, I'm going the entire circle. So this goes from 0 to 2 pi. Okay. So how we write our triple integral is z always comes first. And then r, then theta. Okay. And we multiply by r. So this is a bit of a trick question that since we weren't given the actual function equal pi, we're just going to as 1. So dz, dr, d theta. All right, so this is just going to be z because there's a portion of it. So it's going to be r, z evaluated at each one individually. Right, so plug this in. That's the first one, and then minus and minus, same thing. So this becomes a plus, and I actually have 2 copies of this, so it just becomes 2r of this. Okay. Now, this is one thing I've noticed a lot of you guys when it comes to the quizzes, is you guys try to do everything at once, and notice I'm just doing one. I just didn't bother looking at that, right? I'm just looking at this part right here, because it said z, right? My focus is here, or like a magnifying glass. Okay. Now I'm done, right? I literally finished that integral, and now I go back and do the rest. Put that there. Okay. And again, I'm only looking at this, right? I don't care about anything else. So now it says respect r, so in this one I actually have to do a u sub. So let u equal everything on the inside. All right, so the good thing is this time around, the 2 is here, right? I need 2r dr, and I got 2r dr, but with this negative. So the only difference is I just got to change the negative. So put a negative in the front, integral of the square root of u du, right? Because again, that only goes there. Everything else gets substituted. This I can write as u to the 1/2. So it makes it easier to take the integral. So adding 1 is u to the 3/2 divided by itself. And that's it, right? And this gets evaluated 0 and 1 once I plug in u again. So what was u? This portion. Okay, so plug in 1. This gives me 1, so 4 minus 1 is 3. So this is 2/3, 3 raised to the 3/2 power. Minus, plug in 0, that's 4. So 2 over 3 times 4 raised to the 3/2 power, which I don't know really what that is. Let's see. My calculator gives me something like this. So something like that. So it's going to be negative. Negative 1.9-ish. And then with this negative on the outside, it makes it positive. All right, so again, this is just the second part, right? Notice again, I don't do everything at once. So this is just the answer to the second integral with r. Now I go back over here and do it one more time with respect to theta. So this is just going to be 1.9 theta, and you just plug in at 2 pi and 0, so just times it by 2. So the answer is 3.8 pi. Right? So here's another one. This is number 30 on the same section, 15.7. Okay. All right, so this one is just, you want to evaluate the triple integral, which is messy, right? So this is what we did in class, so it shows you which one's associated with. So z is first. This goes from 0 to 9 minus x squared minus y squared. Then y goes from 0 to square root of 9 minus x squared. And then finally x goes from negative 3 to 3. All right, so if we convert this to cylindrical again, right, because we have x squared and y squared, so this breaks down to our new z, is 0 and 9 minus r squared, because then if I just factor out a negative, I get that. So this is our new balance for z, and I need r and theta. Okay, so we got to figure our radius of our circle. So we can go here and just rework our way backwards if you want. So let's show you how I do it. So bring it over, and we have our radius. So it goes from 0 to 3. Again, this is r squared equals 9. Our radius cannot be negative, so it goes from 0 to 3, which shows you here, right, the radius of our sphere. All right, lastly is theta. Since we're going all the way around the circle, we go from 0 to 2 pi. Or actually, let's see, this is just the top half. Oh, so we only want the top half, so we just go from 0 to pi. Yeah, this is only the top half of the circle. So that means in 2D, going from there to there, that's it. So not the whole thing. Yeah, so theta goes from 0 to pi. There you go. Not the entire circle we want. All right, so how does this work out? So triple integral, c again comes first, 0 to 9 minus r squared. R goes from 0 to 3, and theta goes from 0 to pi, again, because we only want half the circle. And this gets converted to, well, we've done this before, right? X squared plus y squared is r, so r, because that's always there, times the square root of r squared dz dr d theta. So taking the square root of r gives you just r, times it by 2 gives you r squared. Okay. taking into respect to z. So again, all I'm doing is this, right? Z first, that's a constant. So constant is just going to be r squared z. Now again, I just plug in what we have. So plug in this minus that, so r squared times that one goes to 9r squared minus r to the fourth. Plug in 0, gets me nothing. So that's the answer to the first integral. Now I do bound and put the same bounds again. And again, I only look at that. Now it's r. So power rule. Okay, so this ends up being 3. So now I just plug in 3 and then 0, but 0 just goes away. So if I plug in 3, my handy calculator, so this gives me about that. All right, so again, now I go back, do the last one. Okay, so this is an easy one. Just put theta. So my answer is just that. Okay. All right, so let's do some more. So this is number 18 on the same section. Okay, so let's see what we get here. So this one says, oh, let me read it because this one has a 18. So evaluate the triple integral where E is enclosed by the paraboloid z equaling x squared plus y squared and the plane z equaling 4. Okay. All right. So again, polar, we have x squared plus y squared. We have a sphere. So we know z is equal to r squared. We also know z is equal to 4 based off that scenario here. So there's our bounds. Okay, so again, what is this kind of looking like? So we have about a can of Coke, and it's sliced exactly at z equaling 4. All right, so there's our radius. Oh, sorry, there's a z, so we got our radius here and our theta. Okay, so for our radius, what do we know? So putting these together, we have 4 is equal to x squared plus y squared. So therefore 4 is equal to r squared. So radius is 0 to 2. And this time we want the entire circle, right? So we want the whole cylinder, so 0 to 2 pi. All right, so back over here, we have r squared to 4, 0 to 2, and then 0 to 2 pi. And z is itself because we're going just cylindrical. So dz, dr, d theta. All right, so this time we actually have to integrate z. So this is going to be, again, I only look at that. Z squared over 2, evaluated at 4 and r squared. All right, so plug in 4, that's 16. Divided by 2 is 8. Minus, plug in r squared. So that's going to be r to the 4th over 2. All right, so that's the answer to the first one. So now again, I just rewrite what I have. And Again, I only look at what's in front of me. So R is next. So again, power rule. Okay, right. Oh, oops. I forgot about R here. Wait, okay. Oops. I can fix it. Okay. Forgot about this R everywhere. So this is a 5. So this is a 6. Now this is a 12. Okay. All right. Kind of fixed it. Let me rewrite this. Yeah. Okay, there we go. That works. 0 to 2. All right, so again, plug in, so 0 goes away, so my answer is 4. So plug in 2, that's 4 is 16, minus 2 to the 6th power, no idea, divided by 12, it's 5.33, so let's say 10.67. Okay, so again, we get a number. So again, that's the inner part. If I do the last part, so it's just going to be times by 2 again. There we go. All right. Still a couple more. So this is number 19 on the section. And let me read it. So this one says evaluate the triple interval with E is the solid in the first octet that lies under the paraboloid Z equaling that. So the first octet is going to be a big thing going forward. Okay. All right, so go back to polar again. Or, well, cylindrical. All right, so the key thing when it comes to this question, let's read it again. We're using solid in the first octet that lies underneath, under the paraboloid, right? So it's underneath this portion. So it doesn't go any lower than the z-axis, so it just stops right here. So it's kind of like that. So it's underneath. So anything under this, so lowest it could go is 0. So our bounds for z are as followed. Okay. All right. So now we do our r and theta. All right, so same process. So if we drop a degree, so, well, we could just plug in 0 for z, and we'll get x squared plus y squared equals 4. So our radius is from 0 to 2. Okay, so this is where the key thing is the first octet, go for theta. So if you drop it 1 degree, and now just have quadrants of 4, we're asking for the first quadrant here. So that means theta is going from 0 to pi over 2. Right, so 0 to pi over 2. All right, so now what does this look like? A bit of a mess, actually. All right, so 0 to 4 minus r squared, 0 to 2, and 0 to pi over 2. And I got to change all of this to it. So times it by r. So we're going to have r squared cosine theta plus r squared sine theta plus rz dz dr d theta. Now this looks like a horrible mess, but remember z comes first and then r, so we don't have to deal with the trig functions until the last integral, which is not that bad. Okay, so again, can't emphasize this enough. I just look at that, and it tells me to do z first. So constant, 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 right? So this is going to be itself with a z in front. Itself with a z in front. And this is the one that has a z, so it'll be rz squared over 2, evaluated at 0, and 4 minus r squared. All right, so again, if I plug in everything for z, again, we're doing z, that goes away, that goes away, that goes, so it's 0. But this stuff is giving me the painful stuff to do. So everywhere I see z, I plug this in. So here it's going to be 4 minus r squared cosine theta plus this is a pain. Okay, we can plug this in. So and I'm going to do each one individually. I got the foil of this. I don't really want to do U sub after this. What does that give you? I think that's it. And then times the r over 2. So 8 r to the third. Oh, this is not, well, r to the fifth over 2. All right, so dr. So this is a constant, so I don't care about this. This is a constant, I don't care about this. So 4r to the third over 3 minus 4 to the fifth over 5, all times the cosine, plus, well, it's the exact same thing. I wonder if I just factor this out. Okay, all evaluate at 0 and 2. Oh boy. This is a mess. Okay, so I did this a little bit in advance. Now I'm thinking maybe I should just do it in fact, but it's okay. So I got this. Hopefully this is right. I'm going to leave it as a fraction. That comes from these two when I plug in 2. And then when I plug in 2 and put all this together, I end up getting another fraction like that. Okay. And now finally, I take the integral from 0 to pi over 2 of d theta. All right. Okay. All right. So integral of cosine, I believe it is positive sign. So it's going to be integral of sine is negative cosine. Should be opposites. And this is just going to be 16.3 pi theta from 0 to pi over 2. Okay, so this is nice because sine of pi over 2 is 1. So we get 64 over 15. Cosine of pi over 2 is 0. That's gone. And this gives me, so plus 8 over 3. That's the first part. Then minus, when I plug in 0, so sine of 0 is 0, so that's gone. Cosine of 0 is 1, so minus 64 over 15. And that's at 0. Okay, so this becomes a positive. So whatever end that this ends up being happening, this becomes a plus. So whatever 128 over 15 plus 8 over 3 ends up equaling 2 is what I got. Oh, with the pi. Sorry, this is the pi here. This is the only one with the pi. Okay. Let's do one more. All right, so this is a different problem. This is from 15.18, or so 15.8, number 23. So let me read that for you guys. 23, okay. So evaluate the triple integral where E, and they tell you E is, right, so that's our ball, where E lies between the spheres, between the two spheres. Oh, okay, so we have a big sphere and a little sphere. All that. So the hollow Earth, that's what we're looking for. So Earth has a hollow in its head. That's a little pun from Godzilla. If you guys watch Godzilla, good movie, good movies, good movies. All right, so since we have spheres, right? There's your hint. We're going to straight sphere, cylindrical coordinates, not spherical, cylindricals. All right, so that one I do not memorize the conversions. Where is it? Here it is. Okay. All right, so we have rho squared is equal to 4, and rho squared is equal to 9, right? Because rho squared is equal to x squared plus y squared plus z squared. If I'm not mistaken, yeah. Okay. We're going to need x squared, so that too. Okay, so that means rho is bounded between 2 and 3. Which makes sense. This is radius of 2. This is radius of 3. Okay. We need phi and theta. Well, the good thing is it's a sphere, right? So theta should go all the way around, which is nice. But the rho, we got to figure out. Well, I'm pretty sure we'd have an idea since, again, it's a sphere, right? So we're going to go all the way. So, but it's kind of like the first example we did earlier, right? So here's my z-axis, and phi goes from, well, how far do I get to the bottom? It goes all the way down, right? So I want that whole portion. So, right, the whole Earth, so the angle literally rotates the entire way. So 0 to pi. Okie dokie. So now comes the hard part. And my mind is x squared plus y squared. I wish it was just rho, but it is what it is. Okay. All right, so x. X equal again. I just had it. Here we go. All right, so x is equal to rho sine phi cosine theta, and y is equal to just the opposites. All right, so we're gonna have to square these and add them together. Oh, okay. So if I square them and add together, notice they have this in common. So I'll have rho squared sine squared phi. I'm going to have cosine squared plus sine squared. And notice this gives you Uno, which is great. Okay, so not that bad. So now we get the triple integral of 2 to 3, then 0 to pi, and then 0 to 2 theta. Oh, sorry. Well, theta first. So there we go. I think that's how we did it, right? We did r theta then phi. I don't remember. Either way, it gives you the same thing. We'll just do that. Okay, so we're going to multiply by our constant. So our constant's always rho squared sine phi times our new function, which is the same thing. Oh, I think we do rho for that's fine. It really doesn't matter. Get the same result. Okay, so this gives me 5 squared, so 5 to the 4th of power, and then sine cubed. Yeah, cubed. Okay, so far so good. Not too bad. All right, so again, like I've been saying this whole video, rho, so power rho here. Okay, and evaluate this at 2 and 3, which is going to be a really big number. Okay, not too bad. Okay, gives me that now. All right, it's not too bad. Okay, what's next? So now I think I did theta next. So theta. And this is nice because there's no theta. So the problem is going to be the disgusting 5 one. Okay, so this just means 0 and 2 pi. So just double it with a pi. So 84.4 pi sine cubed phi. Okay, so now, again, I only did this. I only care about that. So now it's going to be the painful one. That, which is itself is, you know, a Cal 2 problem. Well, we could cheat. I think you don't mind if I cheat. So all I did was just Googled it, and it's going to be, well, I think I gave you guys the general, just was that sine squared, it's going to be the same thing. It just went over the n power is, so if you really want to know where I got this, this ends up being that. So it's just a property. You could prove it, but yeah. Why do we need to prove it? So n in this case would be 3. So this would be 84.4 pi times 1 over 3 cosine to the third phi minus cosine phi. Evaluate at 0 and pi, which is nice. Okay, so now we just finally plug in pi. All right, so plug in pi, that gives you -1. To the third power still gave you -1, so I'll leave this for now. So it'll be negative, this negative, and a negative makes it positive. Cosine of 0 is 1. Cosine of 0 is 1. This is, what do we get? We get this. This makes it negative, so it makes you negative 2/3. This becomes a positive, so 2. Okay, so too lazy to get a calculator out. So this times whatever this subtraction is your answer. There we go. All right, so hopefully this video helped you go over some ways of setting it up and integrating some stuff, especially with the U-subs everyone. I'll go over a little bit more on Wednesday as well.